Okay, today we're going to talk about multiplication properties of exponents. Okay, and we're going to kind of see, they're kind of a little bit difficult at first, but we'll try to make a good understanding of them and be good to go. Okay, first thing we want to keep in mind, suppose you had something like, I don't know, 3 raised to the third power. What does that mean? Well, we know that this just means 3 times 3 times 3. So the exponent represents how many times we're multiplying the base by itself. So that's some terminology we want to have down. This guy here, we call the base. And this guy up here, this is what we call our exponent. Or sometimes people call it a power. Okay? So the base is your bottom number there, if you think B's. And then the little number on top is what we call our exponent. Okay? So let's say you had something like x to the 4th power. Well, your base here is x. Your exponent's 4. This is just x times x times x times x. So now let's say we took x to the 4th and we multiplied it by x to the 3rd. Well, x to the 3rd is just x times x times x. Well, if we combine these together, we see we have 4, 5, 6, 7. So this is x to the 7th. So one thing to notice here is that if you have the same base being multiplied, we're able to just add the exponents. So make sure you write that down. If you have the same base being multiplied, you're able to add the exponents. Okay? So keeping that in mind, we could do problems like, let's say it's something like this. Something like that, okay? Well, we have this guy being multiplied by this guy, and each part is being multiplied. So I can first worry about my coefficients, or the numbers. 2 times 3 gives me 6. Now I can look. I have x to the 4th, x to the 5th. My base there is x. When you have the same base being multiplied, you can add the exponents. So it'll be x, and then 4 plus 5 gives me 9. Then the final thing I need to look at, I have a y here, and a y here. So I have the same base. And then remember, when you have the same base, you can add the exponents when you're multiplying here. Well, y to the 3rd, okay, good. There's nothing being raised up here that we can see. When you don't see anything, you're going to assume that's being raised to the 1 power. Just like this 3 is being raised to the 1st power, and that 2 is being raised to the 1st power. So now this becomes y. 3 plus 1 is 4. Okay? So again, if you have the same base and you're multiplying, you just add the exponents. Not too bad. Okay, now let's look at this case here. Okay. Actually, we're going to try to do, let's try to do one more together, and then kind of go from there. Say you have, blue's kind of dying on us. Let's say you have 3r to the 6th times 3r to the 4th. Take a second to try to do this one by yourself, then we'll come back together. Welcome back. Okay, for this one, first worry about your numbers. 3 times 3 gives me 9. And if you want to, remember those are 3's raised to the 1st power. And if you actually combine them, you have 3 raised to the 1 plus 1. 1 plus 1 is 2. 3 squared is 9. Now we have r. Same base being multiplied, so I add the exponents. And that's our final answer. Okay, the next situation we want to look at is something along the lines of this. Suppose you had 2 to the third power being squared. And let's make it a little bit easier. 2 squared being cubed. But Mr. Pons, what does this mean? Great question. Now our base is 2 squared. So remember before when we had x cubed, we knew that was x times x times x. Our base here was x. Now our base is 2 squared. So this is 2 squared times 2 squared times 2 squared. And then we know each of these are 2 times 2, 2 times 2, 2 times 2. Well, I see I have 6 total 2's. So this equals 2 to the 6th. So one thing to notice and to put in your notes, if you have a base being raised to something, so here 2 raised to the second power, if we raise that to an exponent, all we do are multiply our 2 exponents. So a base raised to a power, raised to another power, you just multiply those exponents. So 2 squared raised to the third power is the same thing as 2, and you multiply those 2 times 6. And we see why that is here. And let's just show another example. Let's say you have x squared, being raised to the 5th power. Well, using our logic, we know this should be x, and then you multiply these 2 to the 10th. But let's just see. This is x squared being raised to the 5th. So our base here is x squared, and we have 5 of those. So x squared times x squared times x squared times x squared. And then each x squared is 2 x's. X, 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 x. And we have 10 total x's. So that right there just shows, this is what we call our power property, that it does work. And life is good. So let's take a quick example of one, see how we do. So let's say you had, 2. So they gave you something like that. Well, now what we can do, using this property here, this is our new base. So I can do 2x squared y times 2x squared y times 2x squared y. Well, now we can do what we just did. Combine my 2's, 2 times 2 times 2, which is 8. I have x squared, x squared, x squared. The same base being multiplied, we can add the exponents. And now all these y's are being raised to the first power. That's good. So now I can take all my y's, same base being multiplied, add the exponents. Okay. One cool thing to notice though, because if you think ahead, okay, this is fine, we can write this out every time. But let's say this 3 becomes like a 50. Do you really want to write this out 50 times? Well, no, Mr. Pons. Good. So let's just kind of look here. Here's our final answer. Here's our original expression. We could just take this 3 and distribute it to each term. So now this equals 2 to the third times x squared to the third times y to the third. And remember, this y here is being raised to the first power. Well, this just equals 8. We already said we multiply these. Same thing here. That's exactly what we got there. So this is a little bit more efficient way. Just distribute that term down to each, or distribute that exponent down to each term, and then be good to go. Okay. Okay, let's look at one more example. Kind of let you be on your way. Let's say now you had, I don't know, sure. Okay, so now we're kind of bringing everything together, and we even have some negative exponents. But don't be scared. Okay, first step we want to do is let's combine all this before we raise it to the second power. And notice everything's being multiplied. Life is good. So let's first combine like terms. I have my 3 and my 2. Those are being multiplied. 3 times 2 is 6. Well, now let's look at your x's. You have x to the negative 2, x to the 4th. Whenever you have the base being multiplied, it's the same base, so we can add the exponent. So I have x, negative 2 plus 4 gives me a 2. Now let's look at y. You have the same base here being multiplied. So now I have y, 4 plus a negative 3 is a 1. Okay. And this whole thing is being raised to the second power. Now we could just distribute. So this becomes 6 squared times x squared raised to the second power. We can multiply those. So it becomes x to the 4th. Y to the first raised to the second power. Multiply those. Y squared. Now we get 36 x to the 4th. Y squared. So just take it one step at a time. Okay. Final thing I want to kind of show you, and then we'll get off to living life. Suppose you have something like this. Let's look at the 3x squared, or 3x to the negative 2. This is the same thing as, we don't want negative exponents here, so we can put this term into the denominator. So we'll switch it from the numerator to the denominator. So this becomes 3 over x squared. So if we want to get rid of negative exponents, we just put it into the denominator. Or vice versa, put it in the numerator if it's in the denominator. So this is something that we got to keep in mind as we're working through these problems. If your answer comes out to be a negative exponent, we want to use this property at the end. Okay. So we're going to try to do one problem on your own, and then we'll come together and work on it. Okay, let's try this one. So you have this whole thing being raised to the negative 2 power. So take a second and try this one on your own, and then come back. Welcome back. Okay. So again, just like before, let's worry about all this stuff, and then worry about that negative exponent at the end. So first 2 times 8 gives me 16. Z to the negative 4th, and I'll use different colors, fine. Z to the negative 4th, well, I don't have any other z's, so that's going to stay the same. Now let's look at y. We have y to the 3rd, and a y over here. Well, y, we don't see the power, so we can assume it's 1. When you have a base, same base being multiplied, you can add the exponents, so that becomes y to the 4th. And again, same thing with the x. We don't see the exponent, so we know it's a 1. So now we have x to the 1st times x to the 3rd. When you don't see the exponent, when you're multiplying the same base, you add the exponents, x to the 4th. And this whole thing is being raised to the negative 2 power. Okay. Now we can take this guy and distribute it to each term. So I have 16 to the negative 2. Z to the negative 4 raised to the negative 2. Remember, we multiply our exponents. So z, negative 4 times 2, is 8. Y to the 4th times negative 2, multiply our exponents. Y to the negative 8. And x, same exact thing. Now I don't want negative exponents, so I'm going to use that property. I'm going to take my negative ones and put them in the denominator. Okay. My positive exponent is z to the 8th, so that'll stay in my numerator. And then everything else will go in the denominator. 16 squared, y to the 8th, oops, x to the 8th. And if you want to look a little bit better, we have z to the 8th. 16 squared is 256, y to the 8th, x to the 8th. There you go. Okay, so that's pretty much using the multiplication properties of exponents. We use the product rule, which is saying if you have the same base being multiplied, you add the exponents. And then the power rule, saying that if we have our base raised to some power being raised to another power, we can multiply those exponents. So make sure you have these down, because this will help you a lot as we move forward in the chapter. Okay? And then the final thing was knowing what the negative exponent